Hello viewers, welcome to Rishraj Classes YouTube channel. We have started one interesting chapter of chemistry, that is chemical reactions and equations, which is first chapter of science subject of class 10. We have already discussed many things which are related to this chemical reaction. That is exactly what is chemical reaction. Then the different aspect like reactant, products, what terms we have to remember while writing the chemical reaction, and the most important thing, that is how to balance the chemical reaction. So all these things are covered in our previous video. If you have not yet watched that video, please check the link. It's shared in the description box. Now at the end of that video, I promised you that in our next video, I'll be explaining the different types of chemical reactions. This is one more interesting aspect of this lesson. So what are the different types of reactions? So how these reactions are classified? On what basis they are brought? That yes, this is this type, this is this type of the reaction. So exactly on what basis these different reactions are classified? The first important thing on which these reactions are classified is how the reactant and products are seen in the reaction. Means depending on the reactant and products, it decides the type of the reaction. So first we will see the four major types of reactions. Yes, apart from these four major types of reaction, there are still more types of reaction that also we will be discussing in this video itself. So first let's see what are the four major types of reactions. Now the first simple type of reaction is suppose if two or more reactants, they combine to form one single product. Means there are two or more reactants. The number of reactants can be 2, 3, 4, but product is just one single product. Such type of reaction is called as chemical combination reaction. It is chemical combination reaction. Let's check one example for this. Here, the example for combination reaction is calcium oxide plus water. Calcium oxide plus water gives us calcium hydroxide. One more simple example is H2 plus O2, it forms H2O. Here I am not balancing the reactions. I am only writing the examples for chemical combination reactions. So the reactions in which two or more reactants, they combine to form one single product, such reactions are chemical combination reactions. Now exactly opposite of this. Now if one reactant, single reactant, if it breaks to form two or more products, such reactions are called as chemical decomposition reactions. Combination means it combines, decomposition means breaking, it decomposes. Here decomposition of reactant takes place to form two or more products. So when one single reactant breaks to form two or more products, such reactions are called as chemical decomposition reaction. Now here example is ferrous sulfate. Ferrous sulfate, if we heat this, then we get here ferric oxide, sulfur dioxide plus sulfur trioxide. See, one reactant, single reactant is breaking to form three products: ferric oxide, sulfur dioxide and sulfur trioxide. I repeat again here, I am not balancing the reactions. I am only writing examples for these different types of reactions. So, one single reactant breaks to form two or more products. It's chemical decomposition. One more example we can write for this decomposition is calcium carbonate. Again, if we heat this calcium carbonate, we get calcium oxide plus carbon dioxide. So here, this is one more simple example of chemical decomposition. One reactant breaks to form two products. So now, let's check one more type of reaction. Now, this is quite interesting type of reaction. Here, one element, when it reacts with the compound of some other element, then this element displaces the element from its compound. Means here, A comes in place of B and B is set free. Means here what A is doing? A is displacing B. So such type of reactions are called as chemical displacement reactions. Here what happens is the active element displaces the less active element from its compound. Now here, why A is able to displace B? Because A is more active than B. Now here, reversible reaction will not take place because B is less active than A. So B will not displace A from its compound. Now here, one interesting example, zinc plus copper sulfate. Zinc displaces the copper from its compound and copper is set free. Copper is set free. Similarly, iron, if we drop in this copper sulfate solution, iron displaces the copper and copper is set free. So here, zinc will displace copper because copper is less reactive than zinc, or we can say zinc is more active than copper. Even in this case, iron is more active than copper, so iron displaces copper from its compound. But here, copper will not be able to displace iron. Why? Because here iron is more active. So here, one active element displaces the less active elements from its compound. Such reactions are called as displacement reaction, chemical displacement reactions. Now, as I said, there are four major types of reactions. Three we have completed: chemical combination, chemical decomposition, chemical displacement, and the fourth one is, now here fourth type of reaction, what happens? Two compounds, they break. Okay, both the compounds, they break and they form here two new compounds. Means they mutually exchange their radicals among each other. So like this, the two new compounds are formed. Two compounds break and two new compounds are formed. Means here what happens? Displacement takes place twice. Decomposition also takes place twice. So such reactions are called as either double displacement or double decomposition reactions. So the example for this is sodium sulfate reacts with barium chloride to form barium sulfate and sodium chloride. Now see, sodium, it combines with chlorine to form sodium chloride, and barium combines with this sulfate to form barium sulfate. Means here sodium sulfate as well as barium chloride, both the compounds are breaking to form the new compound. So such reactions where two compounds break, double displacement takes place. So such reactions are called as either double displacement or double decomposition reactions. Now, as I said, these were the four major types of reactions. Now, apart from this, there are few more interesting types of reactions. Let's check that. Now, in the beginning, I wrote one example, that is calcium oxide plus water. It forms calcium hydroxide. And in this reaction, along with the formation of calcium hydroxide, heat is released. So there are few reactions, okay, there are few reactions in which when the reactions takes place, in that process heat is released. So such reactions are called as exothermic reactions. So the reactions in which heat is released, heat energy is given out, such reactions are called as exothermic reactions. Exactly opposite of this, there are few reactions where heat is absorbed. Heat is absorbed. Without the absorption of heat, the reaction cannot proceed further. For example, here silver chloride. Silver chloride, it decomposes in the presence of sunlight. Means in absence of sunlight, this decomposition will not take place. So what happens here is silver chloride decomposes to form silver and chlorine. So this reaction takes place only in presence of sunlight. Means what here? Heat is absorbed. So in the reactions where heat is to be supplied, okay, heat is to be supplied, heat is absorbed, without which the reaction cannot proceed further. Such reactions are called as endothermic reactions. So the reactions in which heat is absorbed are called endothermic reactions. So the reactions in which heat is released are exothermic, and the reactions in which the heat is absorbed are endothermic reactions. So exothermic and endothermic is quite clear. Now one more interesting type of reaction. Now here one more reaction I will write again. See, here we saw this example for double decomposition, that is sodium sulfate plus barium chloride. It forms barium sulfate and sodium chloride. Actually in this reaction we get the precipitate formation. Means, sometimes when the solutions, when they combine with each other, the product what we get is in the solution form itself. But sometimes there is formation of particles which we can see, visible particles. So such reactions are called as precipitation reactions. So the reactions in which the precipitate is formed, such reactions are called as precipitation reactions. So now one more interesting type of example is quite clear. Let's check one more type of reaction. Now this is one more interesting type of reaction. It's very interesting. Copper plus oxygen, we get copper oxide. Okay. Copper plus oxygen, we get copper oxide. Here, whenever oxygen is added to any element, we say it is oxidized. And such reactions are called as oxidation reactions. Oxidation reactions. Now suppose this copper oxide, if it reacts with hydrogen, what we get here? Here we get copper and formation of water. Now here what is happening? Here in this first case, oxygen is added, means copper is oxidized. In this case, oxygen is removed from copper oxide, means here removal of oxygen is called as reduction reaction. But okay, oxygen is removed from copper, but it's get added to hydrogen to form water. So here, from here oxygen is reduced, but to hydrogen it's added. Means removal of oxygen is called as reduction, and addition of oxygen is called as oxidation. So in this case, here copper oxide is reduced. This is reduced, and here to this hydrogen oxygen is added. So this is oxidized. So in one same reaction, oxidation as well as reduction, it takes place. Parallelly, one is oxidized, one is reduced. Such reactions are called as redox reactions. Reduction, oxidation in the same reaction, so they are called as redox reactions. So redox reactions are also quite interesting. Here, one more example, right? Zinc oxide plus carbon, we get zinc plus carbon monoxide. Now here, zinc oxide is reduced to zinc, oxygen is removed, it is reduced, and carbon is oxidized to carbon monoxide. So here oxygen is removed from one element, it is reduced, and it is added to the other element, it is oxidized. So even this is one example of redox reaction. So oxidation, reduction, and redox reaction. Now the last interesting and concluding part of this lesson. Now oxygen, the element which is present in this atmosphere, it's quite active, and oxidation is the process which easily takes place. We find many effects of this oxidation in our daily life, and the common example is oxidation of iron, and that is nothing but formation of rust. Rusting of iron, yes. So the iron, which is in its original form, beautiful form, if it comes in contact with oxygen in the presence of moisture, yes, because this rusting process is very fast or active, we can say, in presence of moisture. So when iron reacts with oxygen in presence of moisture, it forms rust. Similarly, we find some greenish coating on copper vessels at our home, and the blackish coating on the silver articles at home. So what is this? What is this? Whenever the beautiful substances, whenever the pure substances, if they come in contact with some other things like moisture or acids, then their original quality is harmed, and with the reaction of that oxygen or with acid, one other unwanted thing or coating is formed, and this is called as corrosion. This is called as corrosion. Usually copper, even it reacts with oxygen. Silver, it reacts with sulfur. Yes, it reacts with sulfur content in the atmosphere, and that blackish coating is found on the silver articles. So we can take proper precautions to avoid this corrosion of the articles. You know, iron articles, they are either coated with oil to avoid contact with the air, or the poles and all, they are painted with silver, or they give one different coating to that so that rusting of iron is avoided. Copper vessels, we usually clean it to remove that oxidized layer on the copper vessels. Silver articles, usually we preserve it so that it won't come in contact with oxygen or sulfur in the atmosphere. So when we come to know the reason of the corrosion, we can take proper precautions according to that. Now, the very last interesting thing. Have you ever tried eating the leftover chips? Potato chips, the favorite food article of most of us, right from small child to the elders, all of us like potato chips. But if these potato chips are left over for nearly more than a week, have you noticed the difference in its taste, difference in its smell? It smells quite different, and we don't prefer eating the leftover those potato chips. Why? What is the reason? Your favorite food articles, and you don't like to eat it after 8 days. Why? What is the reason? What is the reason for that difference in the taste and difference in the smell of those chips? Because the fatty substance, the oily part present in that foodstuff gets oxidized, and this is not the desirable change. This is unwanted change in those food articles, that is oxidation of the fatty substances, and this is called as rancidity. So rancidity is one unwanted reaction which takes place in the presence of oxygen, that is oxidation of fatty substances in the foodstuff. So to avoid that, we don't want oxidation of these fatty substances. What we have to do? We want something which will prevent that oxidation, which will stop that oxidation, and such substances are called as antioxidants. And nitrogen gas is the best antioxidants. See, whenever we purchase the potato chips packet from the market, we complain that why they are charging so much for such a big packet, where we find just a handful of chips at the bottom of this packet and the remaining packet is just filled with the air. No, it's not filled with the air, it's filled with nitrogen. So that when you open that packet, you get the fresh chips which do not undergo the rancidity process, which do not undergo the oxidation process. So this was all about our first lesson, that is chemical reactions and equations. So my dear students, if you want us to make the videos on any other topics related to your maths and science subject, you can drop your request in the comment box. We will definitely take care of it. And if you like our videos, please don't forget to share our videos among your friends. To get the updates of such interesting videos, yes, you have to subscribe our channel. And my dear viewers, my dear students, thank you so much for watching this video.